Today we're going to explore kinetic and potential energy, two fundamental concepts in physics that help us understand how objects move and store energy. Energy is a fundamental quantity in physics that helps us understand how systems change and interact. There are many forms of energy, but today we'll focus on the two most common types of mechanical energy, kinetic energy and potential energy. Let's start with kinetic energy. Kinetic energy is the energy an object has due to its motion. The faster an object moves, the more kinetic energy it has. The formula for kinetic energy is Ke equals 1/2 times mass times velocity squared. We can write that as Ke equals 1/2 mv squared, where m is the mass of the object in kilograms, and v is the velocity in meters per second. The unit of energy is the joule, abbreviated as capital J. 1 joule equals 1 kilogram times meter squared over second squared. Let's see kinetic energy in action with a simple example. Imagine a ball with a mass of 2 kilograms. Let's calculate its kinetic energy at different speeds. When the ball moves at 3 meters per second, its kinetic energy is Ke equals 1/2 times 2 kilograms times 3 meters per second squared. Ke equals 1/2 times 2 times 9. Ke equals 9 joules. If the ball speeds up to 6 meters per second, which is twice as fast, its kinetic energy becomes Ke equals 1/2 times 2 kilograms times 6 meters per second squared. Ke equals 1/2 times 2 times 36. Ke equals 36 joules. Notice that doubling the speed quadrupled the kinetic energy. This is because kinetic energy depends on the square of velocity. If we triple the speed, the energy increases by a factor of 9. Now, let's talk about potential energy. Potential energy is stored energy that an object has due to its position or configuration. It's energy that has the potential to be converted into kinetic energy. The most common type of potential energy we encounter is gravitational potential energy, the energy an object has due to its height above a reference point. The formula for gravitational potential energy is P equals mgh, where m is the mass in kilograms, g is the acceleration due to gravity, approximately 9.8 meters per second squared near Earth's surface, and h is the height in meters above a reference point. Let's see potential energy in action. Imagine lifting our 2-kilogram ball to different heights. When the ball is at a height of 1 meter, its gravitational potential energy is P equals 2 kilograms times 9.8 meters per second squared times 1 meter. P equals 19.6 joules. If we lift the ball to a height of 2 meters, its potential energy becomes P equals 2 kilograms times 9.8 meters per second squared times 2 meters. P equals 39.2 joules. Notice that doubling the height doubles the potential energy. This is different from kinetic energy, where doubling the speed quadruples the energy. One of the most important principles in physics is the conservation of mechanical energy. In an isolated system with no external forces like friction, the total mechanical energy remains constant. This means the sum of kinetic and potential energy stays the same. E total equals K, E plus P equals constant. Let's see this principle in action with a simple pendulum. As the pendulum swings down, potential energy is converted to kinetic energy. At the bottom, it has maximum kinetic energy and minimum potential energy. As it swings up, kinetic energy converts back to potential energy.